All right, let's finish off where we were a while back. Feels like a long time. Okay. Remember this notation? This means the second derivative. So d dx means the derivative, and then little 2's means that we want to take the second derivative. So this is the second derivative function. Now we're trying to find the particular solution, which means we need to work our way all the way back to what y is. Now if you're the one we already did, we were given the same function. We did the antiderivative, and then the hint they gave us was a particular coordinate pair for a particular solution to y prime. So then we could plug it in and find that. In this case, we're going to have to do a little bit more work because they didn't give us a particular solution to y prime. Anyway, let's get started here by integrating, anti-deriving. Sorry, we're still talking about antiderivatives at this point. We're doing the antiderivative of this. So remember, the two steps of the antiderivative is to add 1 to the exponent and then divide by that value. So the antiderivative of the second derivative is the first derivative, so dy dx equals, so I would add 1, that's x cubed, and then I'd take 12 divided by 3. So you want to divide by that new exponent. 12 divided by 3 is 4. Add 1 to the exponent. That's x squared. Divide by that new x, that's 3. Add 1. Okay, we don't have a variable here. That's x to the 0th, so I would add 1. When you divide by 1, that doesn't matter. And then don't forget the big deal. We have some constant here, because when we derive this thing, that constant's going to go away. It's going to look just like this. Now in this case, we don't know. Like over here, we could then plug and chug and calculate what c was, and we could go from there. In this case, we don't know that. So we have to integrate again, anti-derive again. The antiderivative of dy dx is y. I'm going to change colors actually. Y equals, add 1, divide, that's x to the 4th. Add 1, divide, that's x cubed. Add 1, divide, that's 2x squared. X to the 0th, add 1, divide, I would get cx. And then again, we need to have a constant. Now we can't call this constant c as well, so we're going to just call it capital D. Okay, now we're going to use both of these hints to let us try to figure out what c and d are. So I'm going to start off by doing a little plugging and a chugging. So y of 0 equals 4. So, I like that one. That one's easy. So when I put 0 in for all of these x's, I would get 4. So that would be 0 to the 4th plus 0 cubed minus 2 times 0 squared plus c times 0 plus d equals 4. That's gone, that's gone, that's gone, that's gone. So we know now that d equals 4. And then let's use that hint to try to figure out what big C is. So I'm going to go back to my y equals equation. I can now substitute this in here, and I can also substitute, I've got an x value of 1, and then I should get a y value of 1. So I'm going to have 1, my y value is 1, equals 1 to the 4th plus 1 cubed minus 2 times 1 squared plus c times 1, and then we just calculated that d was 4. So 1 equals 1 squared, that's, well, I'll just c plus 4. 1 equals 1 plus 1 is 2. 2 minus 2, that's gone. So I get c plus 4, minus it over. Big C then is equal to negative 3. So then don't forget you want to actually write that particular solution at the end. So our particular solution is y equals x to the 4th plus x cubed, going back up here to this guy, minus 2x squared plus, we figured out that c was negative 3, so I'm going to change that plus to a minus, and we figured out that d was 4. What do you think? All right. Okay, so those are the antiderivative. Now, let's get a little bit more technical. We don't call it the antiderivative anymore. We're going to call this thing the integral. So when we are asked to take the derivative of an expression, we have this notation, this verbiage that says, this verb notation that says d dx. That means the derivative of this thing. So now we need an equivalent that talks about the antiderivative. This is what we call the indefinite integral, and I'm going to highlight that. Indefinite integral. We'll talk more about a definite integral after we do the Riemann sums. So this is indefinite, which means we don't know the boundaries. We don't know from where the integral goes. Where does the integral begin and where does the integral end? That's why it's indefinite. All right, so this symbol right here is the integral symbol. It's actually an elongated S. That comes from doing sums, and we're going to do some sums. I'll explain that also with the next lesson. We've got what's called the integrand, the thing that we're integrating, and then you have your variable of integration. So kind of like we have the d dx here, this has got to tell you, this means derive this according to x. This means integrate my function according to x. So it's called the variable of integration. Because the indefinite integral, yeah, so in other words, antiderivative, integration, antidifferentiation, they're all synonyms. They mean the same thing. All right, so we're going to try to now integrate some of these functions. As always, our hint, Corpy's hint actually, hint is to do what? Simplify early and often. So a lot of the times you'll get something that doesn't look like you can integrate it, and you do a little bit of algebra on it, and it turns into something fairly nice. So let's start with this one. I'm going to rewrite this integral. I'm just going to rewrite this part and then when I integrate, I'll remember to have that symbol in there. So I just want to try to clean some of this up. So this can be rewritten as 5. My math voice says we can turn that into to the 1/2 over. My math voice says these both have a 3, so I can factor out that 3, and lo and behold, I get 1 minus x squared. Now remember, so these are the same thing. This then is to the first power, and so when you have two things that you're dividing, you can subtract those exponents. So we're going to end up with the integral of 5 over 3 times, so this is going to be 1/2 minus 1, so that's a negative 1/2 dx, and this is one of those, that's a constant, so I don't care about that. That's just going to be out front no matter what. This is one of those, we had those on the front half. Let me, hold on. We have this, that's going to be one of those antiderivatives that we talked about in the first section. You AP calcers, AP test takers, it's up to you, man. You got to memorize these. I don't have them memorized. So this is the same as what? 1 over the square root. 1 over the square, so that's this one. So it's the same as the sine inverse of. All right, so coming back to this, the 5/3 is just the 5/3. That's no big deal. Constant's a constant. The integral of this, the antiderivative of this, is sine to the negative 1, sine inverse of x. And then don't forget your constant. That's literally 1 point on the whole test. So, or on the free response sections. If you don't have your constant in there, it's gone. I know root grade's pretty hard on that too, which is good. All right. I would encourage you to try to pause, look at this, and try to come up with a way that you could simplify it into something that's nicely integrable. And then we'll start up after you give it a try. All right, let's see how you did. So I would take a look and I would say this looks something like, well, I know sine over cosine. Well, I know I'm going to have to integrate something trig here. So I usually go up into the corner and I do a quick reminder of derivative. So f of x into f prime of x. So this is how I remember all my trig derivatives. So we've got sine. Its derivative is cosine. We've got cosine. It's a co, so its derivative is negative. Then we've got what would make sense next, I guess. Sine, cosine, tangent, I guess makes sense. Tangent's not a derivative of tangent is secant squared. Then I would go back to the top here and do cosecant. Cosecant's a so that's negative, and it always starts with itself and then it becomes its buddy. So that's cotangent. Then we've got secant. Secant's not a so it starts positive with itself and then it becomes a tangent. And then we've got cotangent, that's a so that's negative. So that's going to be negative cosecant squared. And then what I do is when I want to integrate, I want to work from this side and I want to work back to one of these. So I want to mess around with this thing until it looks like something over here, because I'm anti-deriving, I'm integrating, and I'm trying to go back to this side. So sine over cosine makes me think of tangent. So sine over cosine gave me the tangent, but then I've still got a cosine on the bottom, so a cosine on the bottom is a secant. So this thing ends up being the same as tangent secant. I go back up here, tangent secant, yep, the integral of that is secant. So now I'm really integrating tangent of t, secant of t, according to t. When I integrate, I would get secant of t. Don't forget your constant. There we go. All right, I think I can squeeze in one more before my time runs out. So tangent of p plus, okay, I don't have a tangent squared. So I got to do some work with tangent squared. Now this is going in the way back machine. But this is the kind of stuff they expect you to remember. If you got your old unit circle out, tangent of x is equal to secant squared of x minus 1. It's one of those old identities from our trig proof days. So now I'm going to take that, I'm going to do a substitution. So this is going to become the integral of secant squared of p minus 1 plus 4 according to p. I can combine some like terms here. So this is the integral of secant squared of p plus 3 according to p. Now this is, I'm hoping this is on my list up here. Yep, there it is. So the integral of that is tangent. So the integral of secant squared is tangent. Don't forget your variable. The integral of 3 is 3x, but we're talking about this according to p, so that would become 3p. And then don't forget your constant, plus c. I don't know if I could do the next one in 2 minutes, so I'm going to pause, or I'm going to stop here, and then you guys can check out the next video.